This is the OpenStax website, the math part for that, and this is our book for this class. Again, it's free from OpenStax, Contemporary Mathematics, and it has statistics chapters in it, but I took examples from this particular book here, so statistics itself on regression curves, because it has a few more examples that I want to use. So you will see some of those in this unit, and the first one is actually posted right here. So if I downloaded this one here, I would go to this page here in this table, or if I access it, then it would be this particular link. So I can right click on this one here, open a new tab, scroll down and find a table 1223. Here it is. So this table gives the gold medal times for every other Summer Olympics for the women's 100-meter freestyle. And by the way, I also downloaded it here. Again, this is all free from OpenStax. This is the same table, you know. So we are going to record those data. So table as usual, y1, x1, y1, and now I'm going to put in the years and the times. And notice when I do that, I'm not going to put in 1912. I put in 12, 24, 32, 52. It'll just make it easier for the math itself to calculate. So 12, 24, 32, 52, and so on. And then the times, I have this on the side here, is 82.2 seconds, 72.4 seconds, 66.8 seconds, and so on. And then when I click on this one here, it should show, there they are, there are the first data. Kind of looks like a straight line, but you will see that it won't be a straight line. If you look at these data here, yes, the times are getting better, which means they're getting smaller. Women are getting faster. But then it kind of seems to hit a threshold, right? So that means you could try a straight line, but you will see it's not going to work. So here are the particular curves that we had in the past unit, such as the square root relationship, the square relationship, the exponential relationship, and here's the straight line, and you will see that, yeah, you're going to get a certain curve here, and I would advise you to use this exponential here. So y1 equals m times e to the you would have to put a parentheses here into decimals, so parentheses k times x1, close the parentheses, and then actually do behind make a plus b, because otherwise it's not going to work. So as I said, I would advise to do this one here, y1, even though it doesn't look like that yet, but you will see that it will. So y1 is proportional to m times e to the power, parentheses, k times x1, close the parentheses. And as I said, in this case, you will see that this plus b will help. Yes, they're still looking kind of like a straight line, but again, you will see. So, one of the questions I will be asking in this particular unit is, in the statistics book or in our contemporary mathematics book, they're throwing data at us. How can we be sure that these are correct data, that they're not just made up? So we need sources or citations. I'm going to start out with this one here because it's very straightforward. There are the recorded times for the Summer Olympics, and one of the places to check is actually Wikipedia. Here it is. So here for 1912, unfortunately they didn't put the times up front here, so when I click on details from 1912, there they are. And I'm going to scroll all the way down to the finals. Let's see, here it is, and there's the time, right? 1 minute 22.2 seconds, so that's 82.2 seconds, right? And when I go back and I click on the next one that they have, so I skipped 1920 here because I said, kind of like every other. So 1924, and scroll all the way down, and there was the winning time, 72.4 seconds, and that's the times that you see right here, 82.2, 72.4. So that would be the source. And hence, when you copy these times over here, yeah, that would be the source, and they're reliable. You can look them up in other books, other websites. They have recorded them, or they have been recorded. All right, I also like you to add the men's times. So I'm going to go into this table here. I'm going to go over here, and instead of typing Y2, I'm going to type Y11. It's just going to make it more easy when adding all the other data, because you will see that there will be one relatively big Desmos sheet, which will be still hopefully organized. All right, so they're not in this book here, the men, so they only put the women's in here. Well, these men's are just as easy to find. So if this is the women's here, I'm going to go back here. This would be a listing, unfortunately, without the times, 100 meter freestyle. And then here is the men's, which then the title you can see is List of Olympic Medalists in Swimming, men. Scroll a little bit down, 100 meters. Here, fortunately, they actually did put the times up front. So we're going to start just like the women. So ignore the 1896 and 1908. So start just like the women with 1912. So this would be here a 63.4. Skip the next one. Then here, this would be a 59.0. And with my short-term memory, maybe I'm going to remember that. So 63.4. And what was that? 59.0. And then I'm going to look up 1932. So there it is, 58.2, and so on. And so you're going to choose the same ones then for, the same years for men and women to plot in here. And then I would advise that you use a really similar equation to that. By the way, in Desmos, I can do highlight, Control-C, and then Control-V, or I can retype it. And in this case here, because I used Y11, I would actually use Y11 on this one here. And yeah, it's not going to look like this here, all right, because you're going to have more data. But as I said, I advise you to use the exponential functions for these. And just because I don't have all the data, I'm just going to take the curves off the graph here. Then you would still have to answer a few questions here. Do the data make sense when you look at them? Well, yeah, they're getting faster and faster, but then they're going to peter out, right? What kind of regression curve? Well, I kind of gave that away, right? The exponential should work. What should happen? What should happen to the gold medal times in the near or the far future? Well, they should actually peter out. So they should hit a bottom. There shouldn't be faster and faster and faster. That's just not possible. But there should be hitting a plateau at some point. Well, look at the exponential curves once you have them in there and see if that's true, and see if they're maybe a little bit too fast according to the exponential curves, or if they're right on. So yes, answer those questions as well. And by the way, these questions would be then posted right here to be inserted with your comment, and then post your Desmos link.